So in this video, we are going to discuss the general overview of first unit, a transmission line theory, and basic concepts of transmission line. So our subject code is EC8651 and transmission line and RF system, the 2017 regulations. So now we will discuss about the general overview of the first unit. So what are the topics covered by the first unit? The unit 1 covers waveform distortion, the distortionless lines, and loading and differential methods of loading, and line not terminated by the characteristic impedance Z0, and reflection coefficient, and input and transfer impedance, open and short circuited lines, reflection factor, and reflection loss. The most important topic in the first unit is the general transmission line solution, and then line not terminated in Z0 and distortionless line. Though these three questions are most important. So these questions are frequently asked in the Anna Institute examination. So first we will start with the definition of the transmission line. So what is a transmission line? So the transmission line is generally described as a circuit with distributed parameters. That means a transmission line is a distributed network. So the electrical lines which are used to transmit electrical waves along them, they are called transmission lines. The transmission line is theory of propagation of the electrical waves along with transmit lines. The transmission lines are assumed to consist of pair of wires which are uniform throughout the whole length. The general transmission parameters are like resistance, inductance, capacitance are physically separable, unlike circuit elements of lumped circuit. So the transmitter parameters are distributed all along length of transmission lines. That means line parameters like resistance and inductance, capacitance are uniform throughout the length of the transmission lines. That's why it's called as distributed parameters. So unlike the lumped line parameters, these parameters will not be uniform throughout the length of the transmission line. So hence the method of analyzing the transmission lines is different than the method of analyzing lumped circuit. So this slide shows the general characteristics of transmission line. So the propagation delay per unit length and characteristic impedance, and per unit length capacitance, per unit length inductance, per unit length resistance and conductance, these are general characteristics of the transmission lines. So what is the resistance? What is the resistance? So resistance uniformly distributed along the transmission line. So depending upon the cross-sectional area of the conductors, the transmission line will have resistance associated with them. It's denoted as R. So what is the capacitance? So the capacitance, the transmission lines consist of two parallel conductors separated by the dielectric like air. Such a parallel conductor separated by the insulating dielectric produces a capacity of X, which is also distributed along the length of the conductor. It is denoted by the C. Another one is the conductance. The dielectric in between conductors was not perfect, hence the very small amount of current flows through the dielectric called as a displacement current. This is nothing but the leakage current. This leads to the leakage conductance associated with the transmission line. This is denoted as a G and measured in the mho parameter. So these line parameters constant, it is also called as a primary constants of transmission. Very important. These parameters called as a primary constants of transmission line. So the ideal T line. So ideal means lossless. There is no loss between the input side and output side. This is the ideal line. The ideal characteristics of the transmission lines. The ideal TL assumes the uniform line, perfect lossless conductor, and perfect dielectric material. We only consider and denote characteristic impedance and capacitance and length. A transmission line can be represented by the cascade network of these equivalent models. So the smaller subsection of the more accurate model, the delay of each subsection should be no larger than 1/10th of the signal rise time. So when does the T line become the T line? So when we use the transmission line analysis techniques versus lumped circuit analysis. So why we prefer the distributed circuit analysis over the lumped circuit analysis? So whether it is a pump or mountain depends upon the ratio of the size to the vehicle of size wavelength. The circuit parameters such as resistance inductance, which are lumped discrete points in circuit, can be identified definitely and known as lumped parameters. So these circuit parameters which are distributed along circuit individual parameter not possible, known as defined as distributed parameters. So similarly, whether the knot line is to be considered as a transmission line, so it depends upon the ratio of the length, that means a delay, to the wavelength of applied frequency or rise fall signal. That's why we will prefer the distributed line analysis technique over the lumped circuit analysis. Because of the entire parameters, the primary constants, resistance, such as resistance and inductance and capacitance and conductance, distributed equally all over the length of the transmission line. So next we will discuss about the how to model or how to explain the transmission line behavior. That means the analysis of the transmission line. So like the line parameters. The line parameters are, the important line parameters are resistance and inductance, capacitance, then conductance. The resistance unit is ohm, the inductance unit is like Henry, the capacitor unit is a farad, and conductance is the mho. These parameters called as primary constants. Already we will discuss earlier in the previous slides. Next, the secondary constants of the transmission line is the propagation constant and characteristic impedance. Propagation constant is denoted by the symbol gamma, and characteristic impedance denoted by Z0. These two parameters are called as a secondary constant. Short line. Second one is a short line. The short line means the practical line of the finite length. The short word does not indicate the information related to the actual length of line. As it is a practical line with finite length, it is called as a finite line. So the finite line which is terminated in the characteristic impedance behave as an infinite line. This means that its input impedance will be Z0. There will be no reflection. So the symmetrical T network mostly used network in the transmission line. The transmission line equations for the short circuit, the propagation constant is a gamma equal to alpha plus j beta equal to root of Zy. The Z is commonly represented as R plus j omega L, and admittance is commonly represented as Z plus j omega C. Here alpha is the attenuation factor and beta is a phase factor or velocity factor. The characteristic impedance equation Z0 is represented by the ratio square root of the ratio between the impedance and admittance. Root of R plus j omega L divided by Z plus j omega C is the characteristic impedance. So the characteristic impedance of the line. So what is the characteristic impedance of the line? The terminated transmission line that is matched in the characteristic impedance called as a matched line. So the characteristic impedance depends upon the electrical properties of the line according to the formula. So I explained the particular concept of the characteristic impedance in individual video. So I will share the video to you. So the characteristic impedance is a big topic which will decide the entire part of the transmission line behavior. So the characteristic impedance, the parameter is very important parameter of in each and every analysis of the transmission line. Okay, I will share the separate video for the topic of a characteristic impedance. So the characteristic impedance depends upon the electrical properties of line according to the formula equal to Z0 equal to root R plus j omega L and R plus j omega C. So these are the various solutions of the transmission line. This is the transmission line generally the transmission analysis generally described as the voltage and current analysis. Okay, the voltage and current analysis. A line is terminated in Z0 behaves as an infinite line. Consider the line in terminated Z0 and divide into a number of identical sections of unit length. Okay, here the final analysis of the transmission line gives the following solutions. So E equal to voltage, consider as a voltage E equal to ER into cos h root of ZYS plus IR equal to Z0 sin h into root ZYS. So and I equal to IR plus cos h root of ZYS plus ER divided by Z0 into sin h root of ZYS. So this is a general solution of the transmission line. I will also share a separate video for the general solution of the transmission line. This is a very important 13-mark questions. So this is a very lengthy derivation. I will share a separate video for the transmission line. We will discuss this topic in next video. So these are the solution of the transmission line. So when the line is terminated in the Z0, the characteristic impedance equal to Z0 equal to ZR, the above equation reduced to the ZS equal to Z0. That means the equation of the input impedance and the characteristic impedance.